Okay, hi everyone. So let's get started with the first lecture. So these are all topics we're going to talk about today um, that we'll kind of revisit throughout the semester or our 4-week semester rather. Um, but I just kind of want to give you an overview of them and how they connect to the bigger picture of science, of psychology being a science. So we'll talk a bit about basic versus applied science, goals of science, and the actual scientific method. So just a quick little exercise first. Um, what do you think of when you think of biology and medicine? Maybe just pause the video, write down like the first four things that come to mind for biology, first four things for medicine, and then also do that for psychology. Once you're done with that, then you can just resume the video. So a lot of people, when you think of biology, you probably think of, you know, science and working in a lab, doing research, that sort of thing. Whereas medicine, you think of the more um, practical aspects or maybe application of biology. So you think of someone actually prescribing you medicine, assessing you, figuring out what the problem might be, working with people to address their illness or whatever it might be. So kind of different from biology. Psychology is kind of both, right? It's kind of in a broad field that involves um, research like biology, so people just working in a lab, trying to better understand, various things about um, human psych, human psychology. But it of course also involves um, actual practice, so working with um, clients or patients if you're a clinical psychologist or a counselor, um, working with people who might have certain brain injuries or brain damage, assessing them, doing that stuff. So psychology is kind of a mix of, the one end of the spectrum where it's more, research heavy, but it's also more applied and also kind of more of a practice, right? One thing I will sometimes hear is, well, not directly, but indirectly here that people who aren't really interested in the research side. So they're more interested in psychology as a practice. They want to work with clients or something along those lines, whatever it might be. They say, I don't really like research. I don't really like stats. It's not useful to me. Well, that's totally fine. You can, I'm more on the research side. I love doing research. That's kind of my passion. But if that's not really your passion, it's still really important for you to understand research methodology. So, kind of what I wanted to start out with is just before we get into these topics, get you thinking about how even if you don't want to do research, even if you don't want to go into research, it's still pretty important to understand various aspects of research methodology and stats to some degree as well. So, for example, um, if you're working in a clinical setting, or let's say you're a counselor, you're going to have to decide, what kind of treatment methods you're going to use. So, are you going to use cognitive behavioral therapy, or are you going to use some other thing? That's pretty much the extent of my knowledge about counseling. But um, bottom line is, or if you're in a clinical setting or any setting really, you're going to have to, think about how you want to approach a problem. Well, where do you think that decision is going to come from? It's going to come from research, of course. So even though you might not be directly doing research, you still need to understand that research, right? You need to understand what's been tested as a viable means for treating anxiety, what's been tested as a viable means for treating depression or anger issues or whatever it might be. So even if you're not doing research, research is, of course, critical to your field. And even just in taking classes, upper level classes, it's very important to understand research methodology as well. It's very important to consider things like how something was tested, how it was established, how strong is the evidence, can we trust it, can we use it? And I don't really think you can do that without having a good understanding of research methodology and learning to think about, well, just as some examples that we'll talk about throughout the course, is there strong evidence for this brand of therapy? Is there, you know, causal experimental evidence of this approach to therapy, whatever it might be? That's stuff you need to consider for sure. And critical to that is understanding research methodology. It's also just useful in everyday life. So even if, outside of your field, let's say, you go into a totally different field and you don't really do psychology. Well, it's really useful to think about these things just in a lot of different areas. So I'll give you an example. I compete in powerlifting, and I come across studies about what's the best way to lift, what's the best programming, all this kind of stuff about diet and nutrition. And it's really useful for me to be able to think about those things, even though that's not my field, just from what I've learned about research methodology. So, how strong is the evidence? Is it consistent? Is it correlational or is it experimental? So on and so forth. So, and there's a lot of other situations like that. You might be reading about a poll that say whatever percent of Americans think this. Well, how reliable is the poll? Is the sample representative? And it's really useful to be able to think about these day-to-day things through kind of that critical lens and understand which you kind of gain through understanding the research methodology and ask questions like those before just accepting something a little bit more, with less caution. Okay, so that was kind of my sales pitch on why this stuff is important, regardless of what you end up wanting to do. But so let's move on and talk a bit about basic versus applied research. So, and how they're very heavily connected. So, psychology is going to be a mix of what we call basic and what we call applied research and everything in between. Basic research is something a bit more like biology, where it's knowledge for knowledge's sake. Knowledge is sake. So you might have a theory about how memory works, or how cell division works, or how the brain works, or how we interact with other people, or what motivates us, whatever it might be, right? You don't really have a specific application in mind, but you're more interested in knowledge for knowledge's sake, like I said earlier. And I mean, there's not, again, doesn't mean it can't grow into something more applied, but just by itself, it's meant to be more basic and more about understanding how something works. Something more on the applied end of the spectrum would be something like medicine, most of the time, not always though. And you're kind of more motivated there to improve a real world problem or address a real world issue. Um, so that might be something like how can we get teenagers to not start smoking? Um, Something like that, right? What's a good study strategy for students to use? Okay. And then kind of illustrating this point I made earlier that they kind of feed off each other. You have translational research, which is a specific type of applied research where you use theory or previous research to address problems in the real world. Okay. So I might, draw on some literature about um, social attitudes or social norms and use that to how, inform as to how we can prevent teens from starting smoking, or draw on some basic memory research to understand what's a good study strategy for students to use, right? Okay, like I said earlier, psychology is going to be a lot of both. It's going to be applied and it's going to be basic and anything in between. So basic might be things like what causes forgetting, motivates people, how do we perceive depth, so on and so on. I kind of covered this already, but what is the best applied might be what is the best study strategy? How can we motivate people to eat better? What causes teen drinking? Stuff like that. But again, kind of building off this idea of how um, the two feed off each other in translational research. Um, you might start with a question like, what is an effective way to encode information? That's a little bit more basic, but somewhat applied. And we find out that taking a practice exam or practice test is a good way to study. Um, well, you might take that and apply it. Say, can we use that in classrooms? Can we use a practice exam in the classroom? And then that might go back to the more basic side of, well, why does that work? Why does giving yourself a practice test seem like such a great way to study? Again, bottom line is just that there's a lot of back and forth between more applied and more basic research, and it's rare that you have one without the other. They feed off of each other. Okay, so moving on from there, let's talk a bit about psychology as a science. So what are some qualities that make something a science as opposed to something non-scientific, and how do we implement that in psychology? This is obviously kind of an overarching question from the course, but we'll kind of review, or not review, but kind of foreshadow a few topics and just get you. Well, in general, science has four goals: description, explanation, prediction, and control. So we'll go through each of these individually. So description kind of starts with, it's kind of the earliest phase of research. It's really just discovering something or investigating something to see if it happens. So you're not really trying to figure out, why or being able to change it. You're just identifying something. So a descriptive question might be, do a lot of teens use drugs or do a lot of teens smoke? When does this happen? Like at what age group or time during school? Stuff like that. Um, Another goal is explanation, kind of building off the description. So once we know that something does happen, okay, well, why does it happen? Why do teens decide to do drugs, or why do they decide to smoke? Um, why do we forget things? Why do we, you know, find some sources of information believable, sometimes not, stuff like that, right? Why does the same person sometimes do drugs and sometimes not? Right? So big emphasis on the why. Another one, the third one is prediction. So when might a person do drugs? Which person or which group of people might engage in behavior? Are there certain personality traits or um, locations or whatever it might be more likely to engage in smoking or drug taking? And then the last one is control. So can we get teens to not do drugs? Can we actually change their behavior, implement some sort of a program or intervention, and actually change their behavior, get them not to start smoking? Um, So a big thing here is that, again, just like basic and applied research, which kind of ties into this, these things all come together. Well, they all kind of feed off of each other, and a lot of, you know, back and forth between them. It's kind of tough to have one without having others. So obviously, you can't really think about explaining behavior or understanding why do people do this? Why do they start smoking? Obviously, if you don't actually know if a lot of people smoke or not, right? It's also pretty tough to be able to predict behavior if you don't have a good explanation. So if I don't really have a theory or explanation as to why people start smoking, it's pretty tough to be able to predict why people, or sorry, when people smoke. And of course, same goes for control. It's really hard to be able to, actually control or change behavior when we don't understand it or haven't even described it yet or can't even really predict it, right? So if I don't have a good theory or a good explanation for why teens start smoking, it's kind of hard to intervene and get them to actually take a different route. Okay, so what are some qualities of science? Right? When we think of science, we probably think of, you know, some dude in a lab coat, um, working on a beaker, like in a chemical lab, chemistry lab. But what is science actually? Um, what defines science? So, just to take a step back as well, I mean, you're only in your second year, so probably haven't taken a ton of, enough psychology courses yet. But the more you take, you'll kind of realize that psychology is not. It's not Sigmund Freud. It's not about speculation. It's not about, you know kind of wonky stuff. It's all about science. It's all about empirical observations. It's data driven. So that's kind of a big quality of science. It's something that we consider very important in psychology, is that we have to rely on empirical observations. If you can't, translate something into some sort of empirical observation, well, then it's an interesting conversation at a bar, right? It's not an actual piece of science, right? And that's fine. Certainly talk and have ideas and opinions and stuff, but it's not really accepted, or well, nothing's fully accepted. But it's not really, um, it's the right word here. It doesn't attract too much interest, if any, unless it's actually empirically testable. So is it something that we're not just going to think about and speculate about, but something that we can possibly manipulate, definitely something we can observe, and something we can measure? So manipulating is not always something we can do, and we're going to talk about that a lot later. But um, observing and measuring are two kind of critical parts of science and psychological science as well. So, I always think back to Sigmund Freud. Um, the guy is so full of crap. It's like it's not even funny, because he basically relies on stuff, or relied, because no one ever talks about Sigmund Freud unless they're making an example of what psychology is not. Um, he had all these great theories that were, you know, interesting, I guess, although weird. But the problem with them, and why they're not really scientific, never were scientific, is that they're not really testable, right? So all those theories about, you don't really have to know this, but um, latent, unconscious, um, sexual feelings towards, like, what was it, your mother or your father, some crap like that. It's stupid, because it's unconscious to the point where we're not aware of it at all, and we can't really observe it or measure it. So if we can't observe it or measure it, then there's no point really discussing it because it's not an empirical question. Kind of the same thing, just a little trivia here applies to consciousness. So consciousness and kind of the experience of like what is it like to be a person. Um, you don't have to know this part, but it's a fascinating field for sure. But it's wonky as a science because consciousness is not something you can necessarily quantify, at least not to my knowledge. So kind of separating out a cognitive process from the actual experience of remembering something is very difficult to do. Well, I would say impossible. So that's where it kind of dips into more of a philosophical debate rather than a scientific. And that's doesn't mean it's not useful, but again, it's just not really what we do for the most part. So another big thing when it comes to science is that it has to involve variables. It has to have at least, I would think, at least one thing that can be measured, again, that can take on more than one value. So again, looking at something like what is, unconscious sexual feelings. I mean, if you can, yeah, that's not totally, I'm sure there is research on that, and there probably are ways to quantify that, but I'm just thinking back to Freud again, where the specific way he described it was totally unobservable, totally not measurable. There were no actual variables. But if you can actually find a way to quantify, to put something, into an observable thing that can change values, then go for it. So if something doesn't change values, then it's not a variable. I might look at the number of words recalled, the number of mistakes made while driving, whatever it might be. But there has to be a variable that can change in number. Okay, so kind of let's take a look at the actual research process. So this is something that you can kind of get get a sense of, not the collecting data part. I think you do that in 350, and you'll definitely do that if you take my cognition lab, which is a fourth year lab course. It's fun. I'd recommend it. But you'll kind of get a bit of experience with these things. Um, so let's kind of go through this process, just an overview of it rather. So things start out typically with an idea. So just something like, what causes forgetting, what causes false memories. I have an idea about that. That's often the starting point. That can actually come before or after a literature review, but not set in stone. And ideas can totally be from non-scientific methods, but they're still just ideas at that point. So just kind of your anecdotal personal experience of what do I observe people doing? How do I think my memory works? News reports, a TV show, all those are fine for the idea phase. Okay? So when you're just starting out and you're just looking for an idea, by all means, use these things. But that's kind of where it stops. So then we need to get into, it's fine to have an idea from an unsystematic method, an unscientific method, but beyond that, we need to actually translate it into objective, empirical evidence, testable situation. And just kind of on the subject, why do you think we can't use intuition? Why can't we stick with the idea phase and just write a paper based on that? Well, because our intuitions are very unreliable and often mistaken, right? Um, my old supervisor, my undergraduate supervisor, used to say, people really suck at observing their own cognition. And I don't know if it's that bad in other fields like social psychology, but I would agree with them for the most part. People are often very out of tune with what's actually going on. as a cognitive process. And a lot of things can come into play here, right? So when you work with ideas, um, they're just ideas again, because we don't know how reliable they are. We don't know. Chances are, they're based on biases, kind of personal experiences, sample sizes, so on and so on. So we need to find ways to actually translate them into testable hypotheses, empirical data. Also on the subject, or actually, let me just give you an example of this. If you ask people what's the best method for studying, a lot of times they'll pick rereading their notes. They think that rereading their notes is the best way to study for an exam. Do you know what one of the worst ways when you actually test that is to study? Rereading your notes. There's a lot of better methods, like, say, again, actually practice exams tend to be the best way to study as far as I know. But rereading your notes is really not, or rereading your textbook is not a good way to study. Yet it's what people think is the best way to study. And I'm not just talking about, what do they prefer or what do they choose, but you actually sit them down, have them try multiple methods. You say, which one do you think led to the best studying? They say, oh, rereading. And it's the opposite of what you actually think. The bottom line is that was just a little example of our intuitions, our observations can be very inaccurate. That's why we need to, translate things into actual systematic tests. Just one more note, kind of on this idea of putting things into practice. So how do we get kids to stop smoking, for example? It's really hard to do that, based on ideas, based on non-empirical observations. Why? Because the college is most definitely not common sense, right? I mean, we'd like to think that simple things like, I think a good example is the DARE program. I don't remember too much about that. It was like a drug intervention to get kids to stop doing drugs, to prevent them from doing them, and it totally didn't work because it was just based on, common sense, maybe some observations, some anecdotes. It was not based on empirical data. And I'm sure there's a million examples of that where the common sense approach seems like, oh, it would work, but I mean, I guess you could say, unfortunately, humans are more complex, and the way we think things are going to go are often not the way things are going to go. So that's why we again need to follow this process. Okay. Let's see. What do I have left here? So once you've kind of, passed that, um, idea phase, you move on to the actual literature. This is where you look at articles related to your topic. I mean, it doesn't always work this way. Sometimes you end up reading a lot of literature and then coming up with an idea. Um, I'd say that's probably more common, but it's very important. Well, it's essential, really, to know what's out there. What do we already know? If you're about, have an idea about how to get kids to not start smoking or something like that, it's obviously very important to understand, well, what do we already know about that? What have other people already tried? What have other people already tested? And that's where the literature review comes in. So when you do a literature review, you're gonna search through articles, and I'll post a different video on that, but you're gonna figure out what we already know about a topic. So, and also an important aspect of the literature review is not just figuring out what we know already, but how can we take this idea and translate it into a testable hypothesis and an actual experimental or correlational design. That's often a big aspect of the literature review and something that you can gain a lot of from doing a literature. So you might read a paper, you might be interested in, how am I going to test this particular phenomenon? How am I going to test my theory? Well, when doing a literature review, you should come across ideas how other people have tested it in similar ways. So, you know, and this can happen in multiple phases of the literature review, just reading introductions and kind of reading, what other people have done, reading their methods where they actually talk about the specifics of what their study was like, and their discussion on where they might suggest future research. Um, and again, this kind of doesn't always go in the way you expect. So you know, you might start out with, um, you might get an idea again after the literature review, after some more systematic observation and empirical evidence. That could work as well. Your ideas can come before the literature review. Okay, let's see. So when you're actually,